All right, so last video, woohoo. I'm probably as happy about it as you are. Um, what we're going to do in this last video is conclude this problem. So we've found this p-value of 0.251. And what we're going to do now is use it to write a conclusion in context of the problem. And so the first uh, definition given on this page is what's called a significance level. And so we're not defining this type 1 error yet. That's defined a little bit later. But we will just write what the most common significance level is, which is 0.05. And it's usually denoted by this symbol alpha, though we won't really use this a ton. And using this dichotomous conclusion method, we just say that, all right, if our p-value is less than 0.05, that means, I'm going to go back to the graph that we wrote before. That means that this area here is really, really small because that p-value is very low. So that means that our data is really inconsistent with the null hypothesis because we've got some sample proportion that is very far into these tails. So because our data is really inconsistent with the null hypothesis, we reject that null hypothesis. If our p-value is greater than 0.05, then that means, again, I'm going to go back to what we drew on page 5. That means that this area is fairly large and the data that we observed is fairly consistent with the null hypothesis, so we don't reject it. In class, though, we will mostly focus on the second method of writing a conclusion. So there's a few reasons why, but I think we'll talk about them in class. What we will do instead is write down a scale for how much evidence we have for the alternative hypothesis. So if our p-value is less than 0.01, so down here is like 0, so if it's some value less than 0.01, we're going to say that we have strong evidence for the alternative hypothesis. So that would mean that the area in the graph at the bottom of page 5 is very small, so our observed proportion is really inconsistent with the null hypothesis, so we have strong evidence for the alternative. If it's between 0.01 and 0.05, we're going to say that we have moderate evidence for the alternative hypothesis. If it's between 0.05 and 0.10, we're going to say that we have marginal evidence for the alternative hypothesis. That means that the area would be kind of small, but not like super, super tiny like it would be down here. And if our p-value is bigger than 0.1, then we're going to say that we have no evidence for the alternative hypothesis because our data is fairly consistent with the null hypothesis. So then using the scale, what we're going to do, and this will be true for pretty much the rest of the semester, so we're trying to set ourselves up well. We're going to state our point estimate in context of the problem. And we are going to say how much evidence we have for the alternative hypothesis. So there's some amount of evidence for whatever our alternative is in context of the problem. And then we'll say the z-value that we calculated on the previous page, and we will say our p-value that we will get from stat key. what this will look like for this problem is, okay, so our point estimate, that is our sample proportion of matches that we've won in our sample of 50. So we would say, all right, we estimate the proportion of times we win Super Smash Bros. Ultimate games with our 3 friends is, and this is the proportion that we get from the data we've collected, which was the 16 over 50, or 0.32. That's part 1. Part 2 is how much evidence we have for the alternative. Our p-value is larger than 0.1, so it's 0.25 was the shaded area. So our sample proportion is fairly consistent with the null hypothesis, so we're going to find no evidence for the alternative. So there's no evidence. And then we state what the alternative is in context of the problem. So there's no evidence that the proportion of all games that we win is different than 0.25. We plop in our z-value that we calculated, we plop in our p-value that we calculated, and we're done. Okay, so a couple of extra things I'll mention at the very end of this is first off that we will do a ton of practice with this. So usually we just have like 1 handout per topic, but for this one, since there's so much new stuff going on here, we'll actually have 2 handouts, so 2 different additional examples that we'll do in class that will talk about this stuff. So I know it's a lot to take in, but we'll have a ton of other practice in this particular context. And something else that I want to mention is that we are sticking with hypothesis testing for the rest of the semester. So even though there's a lot of new stuff being thrown right now, they all kind of have a similar flow. So as we get more and more hypothesis tests, they tend to get easier and easier and easier, which is awesome. Okay, I'll end the video here, and I hope you have a great morning, afternoon, evening, whenever you're choosing to watch these videos.